Most people focus on electricity used by AI and cloud computing, but there's another critical resource involved: water. Welcome back to Impact Analysis. Each week, we break down a real time event leaders need to understand, not just what's happening, but what to do about it. My name is Jerome Ryan. I'm joined by Mike Janko. Mike, tell us more about our topic today.
We're looking at a growing issue tied directly to the expansion of AI, data center water consumption.
Yep. And today we're going to dive into how much water modern data centers consume, how AI is accelerating the demand for this, and why this is becoming a major infrastructure and environmental issue. So, with that, let's jump in.
Data centers power nearly every digital activity today: cloud computing, streaming, financial transactions, and increasingly artificial intelligence. But servers generate a lot of heat. To keep systems operating safely, many facilities rely on large-scale water-based cooling systems. And the numbers are really significant. A single hyperscale data center, and what that means is over 10,000 square foot with over 5,000 servers, can use 1 to 5 million gallons of water per day, depending on the cooling technology and the climate. In the United States, data centers are estimated to consume hundreds of billions of gallons of water every year. Major technology companies report billions of gallons of water usage every year for their global data center operations.
Yeah, Mike, and I think a lot of us already know this, but artificial intelligence is, dramatically accelerating this demand. Training and operating large AI models require massive computational power. This means more servers, more heat, more cooling. And this is kind of an interesting fact that maybe a lot of people don't know. Some research is estimating that training just a single large new AI model can require hundreds of thousands of gallons of water during processing and cooling. As organizations integrate AI into their everyday operations, the amount of computing power required is just going to keep growing exponentially.
Another key issue, Jerome, is where these facilities are located. Data centers tend to cluster in specific regions with really strong network connectivity and access to power. In the United States, Northern Virginia hosts nearly 35 to 40% of the whole world's hyperscale data centers. When you combine that with Texas, California, Arizona, and Oregon, that's about 70% of all US data center capacity in just a handful of states. Then when we're looking globally, major clusters exist in Ireland, the Netherlands, Singapore, Germany, and Japan. So this concentration means that water demand is not evenly distributed.
Yeah, and some of the locations that you've mentioned in the United States, as an example, are already under water stress. For example, Arizona is one of the fastest growing regions for data centers, as you mentioned, but also one of the most water constrained areas in the United States. Parts of the Western US rely heavily on groundwater reserves that are already under pressure. This is creating a potential conflict between digital infrastructure expansion and regional water availability.
Now let's take a look at energy demand and the strain on infrastructure, Jerome. So water is only part of the equation. Data centers are also becoming big consumers of electricity. Globally today, data centers consume roughly 1 to 2% of global electricity. But with the rise of AI, the numbers expected to increase. By 2030, data centers could represent 3 to 4% of global electricity demand. And in the United States, data centers currently consume about 4% of the nation's electricity, and some forecast that this could reach 8 to 10% within the next decade.
Yeah, and cooling systems add to that demand. In many facilities, cooling accounts actually for 30 to 40% of total energy usage. This creates that reinforcing cycle: more AI, more computing power, more heat, more cooling, more water, and electricity demand. And that places additional pressures on local infrastructure.
There is a lot of pressure, Jerome, on municipalities when they host these large data center clusters. They're going to need big upgrades to their water treatment plants, to pumping systems, to electric substations, and transmission infrastructure. These upgrades could cost hundreds of millions of dollars and take years to complete.
Yeah, and this is where this becomes systemic. Data centers sit at the intersection of those three critical systems: digital infrastructure, energy infrastructure and water infrastructure. When demand rises rapidly in one of those areas, the other two are going to be affected.
So many of the communities and regulators are beginning to raise concerns about several risks. Water scarcity is already stressed in regions, groundwater depletion from heavy pumping as well, and potential groundwater contamination from the cooling chemicals or wastewater. So there's rising infrastructure costs as well for local governments. And in several regions, local governments have already begun reviewing or delaying new data center projects because of the water power concerns. So let's take a look, Jerome, at a few key takeaways for leaders. AI and water usage can become a top trending risk. So think about this. Is your government relations team involved? Is risk management involved? Are your resilience-based folks involved? As AI adoption grows, organizations should start thinking about the physical infrastructure behind these digital services. A lot of actions that can help include understanding where your cloud and AI infrastructure is physically located, evaluate water and energy risks in regions hosting these data centers, assess the concentration risk. If a lot of these services are dependent in the same geographical cluster, and monitor the regulatory developments related to data center environmental impact. A lot of what we're talking about here started in a similar fashion with the ESG initiatives that we know kind of took over and we needed to respond to them.
Yeah, and from my end, Mike, when I look at the risks that are involved, I think the first one here is around cost of electricity. So if you're an electricity heavily dependent company, what would it mean to you if the cost of electricity was increased by 5, 10, 20% or more? I'd also start to look at the availability of the data centers. We are massively heavily dependent on data centers now, not just for AI, but for traditional computing power and data storage. What would happen if the availability of those data centers and the data that you want to access there gets throttled by local governments because they start to put some restrictions around the use of water, the use of electricity to run those data centers? You've mentioned this here already. New data centers that are being proposed are being scrutinized more heavily, maybe suppressed or at least delayed from the local government perspective over these environmental concerns. They really need to start to put together, as part of their submission package for new data centers or expansion of existing ones, how they're going to mitigate the impacts to the environment. We've talked a lot about electricity, we've talked a lot about water, but those additional things such as carbon footprint as well. We need to look at, from the risk side, also the impact on AI in the community. We've seen a lot of discussion around the United States from ratepayers, residential electricity users, having some concerns around the increase in their bills and wondering, maybe rightfully so, that their increased electricity rates are due to data centers and hyperscalers using more and more electricity for themselves. So there really is a conversation happening right now. And again, just to wrap up my end here, water, energy, infrastructure capacity, I've mentioned this before, but it's all going to play a role in the future of how AI is implemented and expanded here.
Well, thanks for that recap, Jerome. And we look forward to seeing everyone next time on Impact Analysis, where we're going to examine another real world event, discuss what happened, why it matters, and actions that leaders should take right now. And as we say on Impact Analysis, you can manage risks now or the consequences later. Thank you.
Thank you.